Hello, hey Mira. It's just you for now, so welcome to this latest lecture in the A Star series. So tonight, this is the penultimate lecture, the one of the current series. And so what we're going to do, we're going to go through a past calculator paper. And just to say, although it's just due for now, it's still going to take the form of a lecture just because these get uploaded to YouTube, more people watch them there. So we need to keep the normal format. At the same time, obviously, if you've got any questions at any point about anything, it's not a problem to put your mic on and ask something at all, whether it's to do with the questions or any general concerns from the course. And so the past paper we are going to go through, just to explain, is actually an Edexcel Foundation GCSE calculator paper. Now, in terms of the format, the Edexcel papers are slightly different from the A Star because they have 80 marks per paper instead of 50. They take an hour and a half instead of an hour. But in terms of the type of questions you get, they are exactly the same because the A Star paper is based on the Edexcel exam questions. And I'm going to share in the chat the paper we are going to go through today and tomorrow. So if you wish, you can load it up and you can either follow along, or if you want to try and sort of jump ahead as well, then that's absolutely fine. Um, welcome, Claire, as well. Welcome, Claire, as well. And Hamad, I'm just going to pop up your mic for now because you don't appear to be asking anything. I think it went on by accident. But if you do have any question, feel free to pop it on at other times if you can keep it off, just because there's a bit of noise coming through. But yeah, Claire, I'm just going to share as well the paper I just put in the chat, which is we're going to start going through today. So we're going to do the first half of the paper today, and then we will do the second half tomorrow. And how it works, the questions get progressively harder. So it'll be the easier questions tonight, and then the more challenging questions will inevitably be tomorrow. I'm just going to share in the chat as well, because I think, particularly in the case of Homer, I believe you are new to the classes, is I'm just going to share the playlist for this series. So this lecture, as always, it's being recorded and it will be uploaded to the YouTube playlist I've just shared. You can also watch all the previous YouTube lectures there. So if you want to look at any of the earlier ones, you can watch it there. And yeah, as always, I'm going to share my screen as I go along. But yeah, if you have any questions, anything's unclear, please do let me know. But we'll start just at the start. And as I said, the first questions in either the Edexcel or the A Star exam, of course, as well as it's based on it, should be very straightforward. I'm hoping these initial questions you won't deem particularly challenging, but they're very important in the early part of the exam because this is where you can get yourself ahead. In A Star, you have the 2 hour exams based on the 250-mark papers. So 1 mark is 1%. So you get a question like this, all right, it's already one of the 55% you need to pass. And so mastering these early questions, getting the marks is really key. Well, here we just got right 1476 to the nearest 10. Well, the 7 is in the tens. And the number after it is a 5 or higher. Welcome, Tess, as well, and welcome, Kutatana. I'm just going to shout again in the chat as you've both entered the exam we're going through in case you want to follow it on your screen or jump ahead. But yeah, we've got the 7 in the tens column. The number after it is a 5 or higher, which means we round up. So to the nearest 10, it will just be 1480. So as I say, hopefully this sort of question for the majority of you will be pretty straightforward. And then here we've got question 2. I'm just going to put on the same bit. So we've got write a fraction in the box to make the calculation correct. Okay, we've got 1 minus 3/10 equals, well, basically, remember, for any fraction to equal 1 integer, and the numerator and the denominator have to be the same. So you could write 1 as 10 over 10 because it means like 10 parts make 1 whole, and we have 10 parts. So we've got 10/10 minus 3/10 is just going to 10 minus 3. It's going to give you 7/10. 7/10, and that's the most technical correct answer there. You could actually put any equivalent fraction you wanted, but there's no need. Just do it as 7/10. Then next we've got number 3 here. So we just got here is a list of numbers, and we need to write down the mode of its numbers. The easiest way to remember which one mode is, it's like the MO sound. So mode, just think of it as most. Again, a full letter word beginning with most. So mode is the most. We can see here we've got 4 different 3s. We've got 2 4s, 1 5, 1 7, 1 8. And so the most popular, the mode, is 3. Okay, so just give a second to copy that down, and then we will move on to the next slide. Okay, so you got here then for question number 4. We are just asked again, we're still on the 1 mark questions here. We're still basically, it's almost like the warm up, the 1 mark questions at the start. Sorry, my mouse has been a bit funny. It's not been overly responsive, so do be patient with me. But we got write down a 3-digit number that is a multiple of 5. Well, the thing to remember, 3-digit just means it's got 3 numbers, but any number that ends in a 0 or a 5 is a multiple of 5. Because if you think about the 5 times table, a multiple just means like equals in times table. The way to remember that is like multiplication. Because if you think about it, it just goes 5, 10, 15, 20, 25, 30, 35, 46, just 5, 0, 5, 0, 5, 0. So this means all you have to do is a 3-digit number which ends in 5 or 0. So I'm just going to put 3, 6, 5, the amount of days in a year, and that will be absolutely fine. But it can be any 3-digit number which ends in a 5 or ends in a 0. Okay. So next we've got here, we have just got a question of write 0.4 as a percentage. And so here, just remember, decimal to percentage equals times 100. You do actually have a calculator. Remember, this is a calculator paper. I've been forgetting that for now. You don't necessarily need to use your calculator on these questions, but you could just do times 100 on the calculator. But if you didn't want to, or if it was non-calc for the same question, which it probably well could be, it means move the decimal 2 places right. 2 places right. So we got 0.4. Got 2 places. You might think there's only one number there, but that means we can add a 0 as well. After a decimal, after the last digit, you can add zeros for error, so it'd just be 40%. But as I say, you could just do times 100 in a calculator if you didn't feel uncomfortable doing that. I should say, by the way, for me, like in basically every past paper you're going to see, to calculate a paper, I would say that that about 75% of questions, at least, or 75% of marks, probably more than 75% of questions, could be on the non-calculator paper. So it's not a case that you get the calculator paper and suddenly everything you need a calculator for. And although there's nothing wrong with using your calculator, you can. I would say from that perspective, it's good to sort of not switch off your non-calculator brain. Still make sure you're using common sense. If it's an easy sum, sometimes it's better to do it without the calculator, because sometimes using a calculator, we can make silly slips and not realize because we just think a computer said the answer, so we don't think about it. Right, here again, a question which could very easily be non-calc. So we've got questions, write the following numbers in order of size, start with the smallest number. Well, remember, if you had like a number line, you'd have a 0 in the middle. The smaller it would get, you get down to minus 100. Well, obviously, it would go beyond 100, but it would go in that direction with the up going up to 100 and beyond, which means the smaller numbers are going to be like the negative with higher digits. So you've got minus 11, minus 7, minus 2, 3, 8, 10. All right. I'll just put that on a number line as well, just to make it clear. So yeah, this down here, and going this way equals smaller. And in this direction equals bigger. Okay, so again, I just give a second to copy it down, and we will move on. So next question, we've got the first part, which is we've got the first part, which is actually multiple questions, and even this, it's like 3 1-mark questions. So we haven't really got into a long form question yet, but it's starting probably to get into the exam for real. So we've got here is a polygon. And you've got to write down the mathematical name of a polygon to start. By the way, a polygon, it just means any two-dimensional shape is a polygon. So write down the mathematical name. Well, it's not, because it's more than 4 sides, it's not going to have a really fancy name, but it's just a name for all of this type. So here we've got 1, 2, 3, 4, 5, 6 sides, 6-sided shape. It's just a hexagon. You could technically write a regular hexagon because not all sides and angles are the same, and it'd be accepted too, but hexagon's absolutely fine. And so next we've got which side of a polygon is parallel to the side CD. Well, CD just means the side between. And remember, parallel sides are lines which always stay the same distance apart, never getting closer. So it's going to be this down on the bottom, which is AF. And next we've got write down a side of a polygon that is perpendicular to the side AF. And so perpendicular, it just means equals at 90 degrees. So 90 degrees, it will make a right angle together. So like if one's directly up, one's directly across, that perpendicular. So we've got AF here, mark it with a dot, and you could do, it says one of the sides, so it could be either A, B, or as I put here, it could be E, F. Remember, just follow the same code they've given. Aside is from the letter at the start to the letter at the end. That's how we write aside. It's going to have E, F, or A, B. If you write F, E, it's not going to cause a problem, but it probably makes more sense here to put it in the alphabetical order. And this is sort of question, to be honest, with shapes, it's a bit tricky because it's obviously very time consuming to try and learn the name of like every shape up to 10 sides, things like that. And you're very unlikely to be asked questions on an individual shape. But of course, there's a chance like this, but you get a general shape question, just we don't know what shape it will be. So having some idea of a different shape names can definitely be useful. Definitely at least wanting to get up to sort of getting towards at least a hexagon, sort of 5 and 6, but ideally you want an up to 10, though for whatever reason an octagon would be more common coming up from, which is 8 sides, for maybe like a septagon, which is 7. All right, here. So here we've got, again, we've got multiple parts. It's not loads of mark. Now, part C, you wouldn't really get in the exam because it's going to be a computer-based exam, so they can't really expect you to draw a circle, but I will explain it when we come to it anyway. But here we've got write down the coordinates of point A for our first part. And again, very straightforward. We can see what A is. Remember, we write coordinates in alphabetical order. So it goes X first, Y second. So it's just going to be 3, 2. And then we're told on the grid, mark with a cross the point with coordinates -4, 3, label it B. Well, again, if we follow X first to -4, then we go up to 3, we can put our X here, and we need to call that B. Again, because of the computer nature of the A-star exam, you might not be asked these questions in exactly the same way, but you very much could be asked these topics on the same knowledge. So you'd have to understand this. You might just have to input it a bit differently. So finally, we're told on the grid, draw a circle with center 1, -1. So this would be the center of our circle, 1, -1. And we're told with a radius of 4 centimeters. So remember, radius is a centimeter grid. So radius is a gap from the center to the outside. So if you had a compass, you can mark it at 4 centimeter, or you can mark it on a 4 centimeter point and then just draw a circle like that. But the circle should go round like this. You can see we've got 4 centimeters there, 4 centimeters there, 4 centimeters there, 1, 2, 3, 4. So you can just count 4 squared from each point. And so this is beyond my drawing ability, but it should be at the same gap at each point. Obviously, without equipment, it's a bit tricky, but you can see, yeah, it'd be 4 centimeters at each of the key points I put there, and so that means its radius is 4 cm. Right. So we'll move on next to question number 9. And actually, this is a little bit of an unusual paper in ways, but although it's got longer questions for 2, 3 marks, they've all been individual parts so far. Often by this stage, you would have had sort of a 3, 4 mark question. But all of these topics are really good ones to practice, these individual little graph questions, things like that, making you confident with it. And it's why going through past papers as much as possible is really helpful, because there's a lot of topics, but to be honest, you don't want to spend ages on it. If you've seen like the A-Star MME book, you've seen the website, has so many topics, so you don't want to spend like a week learning about line graphs or something like that, which is fairly straightforward. But obviously, time consuming with so many topics. It's better just to take on key topics and then do past papers as we do in this course to just try the odd bit of other topics, because a lot of topics, maybe just by seeing your past paper, you can pick up how to do it very quickly. Well, the slight difficulty with this question, of course, is I've got it very small and it's testing my eyes. In fact, I'm going to zoom in a bit as a result. If it lets me. Here we go. So we can see here we've been asked for part A, and they've been a little bit mean on us here actually. To ask how many houses were sold by the estate agent in February. So we can see we've got the X for February because we've got number of houses sold, which is our left, the month here. Well, for February, our X is halfway between lines here. So effectively, we are here. And if we look at it, we've got 1, 2, 3, 4, 5 gaps between 20 and 30. So 30 to 20 or 10 to 0 equals 10. So one line, sorry, this is me zoomed in, I can't write here. I'm going to zoom back out again. Now I've spotted the line. Oh, my writing is going to be very weird. So we've got one line in the graph equals 10, which is the gap between those two places, divided by 5, which is the amount of spaces, equals 2. And so, as we saw when we zoomed in, just like 1.5 up, which is 3. So we can say it's 23 houses. 23 houses. Obviously, in the exam, it's going to be bigger than the version I've got it here, as long as you don't have a teeny tiny computer. Exactly. And I definitely, by the way, I'd recommend that if you're doing a computer-based exam, make sure to try and do it on one with a reasonably large screen. It's obviously gonna help if you can. If not, it shouldn't really be a problem with maths anyway. All right, but for part B, we got for this estate agent, write down the ratio of the number of houses sold in January to the number sold in June. Well, here we have got Jan, we can see easily enough, equals 10. For June, I'm going to have to zoom in again. This is definitely too much for my eyes. But we can see if we go across at 50, can see it's gone up 1, 2, 3 slots. So we can say it's at 56. 56. June equals 56. So if you're just going to write that as a ratio, you can just write it as 10 to 56. Now, you can simplify. It doesn't ask us to, it just says write down the ratio. It doesn't say in its simplest form. If you did simplify, it's not wrong. You could divide by 2 and get to 5 to 28, but it's completely unnecessary. 10 to 56 would get you the marks already, so you'd just be simplifying for simplifying's sake if you did that. All right, so again, I just give a second and then we'll move on to the next question. So we're into question number 10 of a calculator exam. And this question is unique because it's sort of the first one where a calculator is going to really save you some time. It's going to prove really helpful. You could do it without a calculator, but as we've got one here, we might as well use it. And I should just mark on I didn't copy the bit at the bottom, but it's a 3-mark question. So again, it's our first question, really worth multiple marks. The most we'd had for an individual part before now was 2. So we're told Sonia wants to book a holiday. The holiday will cost 1,428. Sonia will pay a deposit of 150. She will then pay the rest of the cost in 6 equal monthly payments. How much is each month's payment? So it's pretty clear here. 1 of 150 is a deposit, and 2 after which she pays the rest. So we need to get rid of our 150 first. So A, we can do 1,428 minus 150, which if my mental maths is not letting me down, will be 1,278. But I'm going to use the calculator as we have it here. Yeah, exactly what equal 1,278. And so now it's in 6 equal payments. So we've got B, we've got 1, 2, 7, 8, divided by 6, which I believe is 213, but again, we're going to double check. 1,278 divided by 6, and yeah, it gives us £213, which is the answer. So as I say, you could do this without a calculator. You just do a bus stop division of 1,278 divided by 6 because it goes exactly. But yeah, it's the first time really having a calculator is going to save you some time. Always do look at your answer on a question like this, even if you use a calculator where the maths isn't, trying to think, is my answer logical? Potentially double check it because you don't want to lose like the key mark on the exam because you slipped on the wrong button or something like that. All right, so the next question we're going to come to, we're going to have a little bit of angles. Okay, so we've got here the diagram shows triangle ABC, and we are told ACD and BCE are straight lines, and you need to work out the angle size of the angle marked X. Give a reason for each stage of your working. All right, so we got a couple of things going on. We got a straight line through another straight line. This creates some angles along the way, and we've got ABC, which is a triangle. So if ABC is a triangle, we can say this angle here, which we can call angle BCA. So when you say like an angle and you write it with the letters, I'm only mentioning this because you might see it on another question where you have to understand this. Basically, where the angle is the middle letter always. So it's like the letter coming in, the letter coming out. So if you drew from B to C to A, you would create this angle, hence this angle BCA. And we can say it equals 180 minus the other two angles in the triangle. So you've got 116 plus 25, which gives us 141. And then if we take that away, it's going to give us 39 degrees. So we can draw that on. And we've been told to give a reason for each stage. I should say this was a 3-mark question, I believe, as well. And we can just say angles. So I'll just put the angle sign because I'm lazy in a triangle. And I think it'd be fine to leave it like that. If you want to be safe, you can always write equal 180 degrees. The fact you've already put the 180 there kind of tells the examiner you know what the angles in the triangle equal. But anyway, now we've got that. although we don't have two parallel lines here, a straight line for another straight line is always going to create angles opposite each other. And so we can say x equals 39 degrees. So it looks the same. You can see the two angles look the same. If you measured them, they would actually have to be the same. They can't draw it different. And so we can just say vertically opposite angles are the same. And so vertically opposite means like the two angles facing each other. If you remember to say vertically opposite, brilliant. If you just wrote opposite, for me, it would be ridiculous for the examiner not to give you the mark. But it's always better if you've got the more technical term, if you've got the entirely accurate term, to put it just in case, because I don't think it's good to bet against maths examiners being ridiculously pedantic or tight. It's much better to have all the technical stuff if you can. All right. So next here, I've got a topic I don't think I've come across in one of these for a while, in one of these classes, so it's a good one to come up. And these are number machines. Number machines are relatively straightforward as a topic. It's not something you have to learn like crazy, but it's good to be familiar with them. There's a 3-mark question. Basically, how a number machine works is so like for a number machine, you start with the input and work from left to right. And so in effect, BIDMAS or BODMAS doesn't apply. You just go in the order. And then the other thing, because I always give this question, if you start from the output, switch signs for the opposites, and so opposites are like times and so should say, let's just say multiplication and division, and addition and subtraction. These are the opposites, and work from right to left. So our second example here will get us doing that. But anyway, we got our first question here, and we just asked work out the output when the input is 28. So all you've got to do is these simple sums. 28 divided by 7 equals 4 plus 5 equals 9. And so that's it. It's 9. Simple enough mark. Next we got here is a different number machine. The number machine is not complete. And we're told when the input is 8, the output is 154. And we need to complete the number machine. So we basically need to work out, well, what times 11 is going to equal 154. So the easiest way to do that, we do have a calculator here if we want it, is we can work in the other direction. So we can do 154, the opposite times equals divide. So we can do divided by 11. And then I think that's just going to give us 14. I'm going to put it into my calculator just to be certain. Oh, 11, yeah, exactly. Sure enough, it gives us 14 at this stage. And then plus what? 8 plus what equals 14 will be 8 plus 6, because 14 minus 6 equals 8. So we've completed our number machine now. 8 plus 6 gives us a 14 times 11 equals 154. So as I say, it's not a horrible topic, number machines. They don't come up too often. It's good to be familiar with them, but hopefully it's nothing which seems particularly taxing looking at that. All right, so I'm going to move on to the next question now. And we got here, again, it's quite a nice topic, this one. I say this and frequency trees are mid-exam topics. They tend to always come up around halfway through the exam. And I think both of them are very similar, two-way tables and frequency trees, and they're both quite nice topics. Again, I apologise, my mouse is playing up, so I'm struggling to move the question around, but here we go. This is a 3-mark question, and we are told Sophie works in a bed shop. During the last 3 months, she sold 198 beds, 59 were sold with a mattress, 45 were double beds, 17 of the single beds were sold without a mattress, 67 of the 83 king beds were sold with a mattress, and you need to use the information to complete the two-way table. So a question like this, always just work your way through the information you have been given and input it. And once you've done that, you solve it almost like a Sudoku. You work out what columns you can fill out and you do the rest. So we told during the last month, she sold 198 beds. So straight away, you can cross that out and just put 198 in the total. And that's the one which is often easy to miss. I find people overlook that first piece of information, which is really probably going to be key for calculations. But we're told 59 beds were sold without a mattress. So we can write without a mattress total equals 59. So again, we can cross that out as we've used that fact. We're told 45 beds were double beds. So again, we can put in total for double. We can put a 45 and cross that out. And then we're told 17 of the single beds were sold without a mattress. So we can put in our 17 here and cross that out. And then we got 67 of the 83 king size beds were sold with a mattress. We've got 2 pieces of information here. 83 king bed size beds were sold with were sold in total, and 67 were sold with a mattress. So we've entered all our information here, and now it's down to us. In any area where you've got all the answers except one, you should be able to answer it. So we can say, like, and again, we've got a calculator here if we want it, but we've got with mattress. We can say equals to 198 minus the 59. So it's just going to be 1, 3, just going to be 139, I believe. Again, we got a calculator here, so we might as well double check our maths. And I wouldn't expect you to just do it in your head first in the exam. Of course you can if you feel comfortable with it, but you don't need to. So we can put 139 there. Then we can go king size without king equals 83 minus 67, which gives us 16. I'm going to put all of the ones I'm putting in at this stage in this color just to differentiate the ones we put in. So we put 139 here. And you can see with the things we've worked out, like the top one there, the one down here, it was absolutely key we remembered to put in a total. If we haven't remembered to put in a total, we'd have hit a bit of a dead end here, but we can say total single equals 198 minus 83 plus 45. So you add them two together, which will get you 128. Of course, you could do this again with your calculator. You just can take one, take the other. There's nothing wrong with that. And then that's going to equal 70. Again, I'm just going to double check that. But yeah, sure enough, that equals 70. So we can mark that in. And so next we've got single with mattress. You wouldn't have to write out, I'm just writing this all out here. You wouldn't have to write out all these sentences. If you can show the maths you've done along the way, that's fine, but it should be obvious anyway. So you've got 70 minus 17, which gives us 53. And then we got our 2 left, which is double with, which equals 139 minus the 67 plus 53. We add them together, it gives us 120, and so it equals 19. And finally, we've got double without, which equals to 45 minus 19, which equals 26. And yeah, if you add up any part of a table, it should all fit together. It's like 26 plus 16, it will give you 42, plus 17 will give you 59. So you can see without mattress adds up, and that should be at any point. If you go back through, if you double check everything, it should all add up together. So a question like that, it's just being reasonably systematic. Obviously, putting it on the calculator. So yeah, my feeling with this, Clay, in terms of whether you could just write what you put in without, I would say yes, you can on this question, because it's very obvious what you've done. There's only 3 marks available, and we're talking about 6 different sums. So my interpretation of that from the mark scheme is yes, you can just fill it out like that. Obviously, the only slight advantage of writing things out is if you make a mistake or you put a calculation wrong, the examiner can see sort of what you did wrong, and so it means you might not get sort of a cumulative error, because obviously if you make one mistake, you can end up making 2 or 3. But the key overall is to be just very careful at all stages. What you could do as well is, for example, on a with mattress, just as a side, just write, for example, underneath, say if you were doing total, just write underneath 198, take 59 equals 139. So not write out all the other details, but just put in the sums you've done at each stage. But you would get the marks with just a table. I'm pretty confident of that. All right. So next we've got a little bit of a different question again, and actually it's a good thing about this paper. It's got a few random topics on it. Like little bits here and there, but we've got here to do with symbols. So we've been given a question here. The box below contains 3 mathematical symbols. We've got equals, we've got the less than, and the greater than. So basically, just to write out with the inequalities here, so say if you've got an inequality, if you're on this side of it, so if you're on the small end of a crock in where the body would be, you've got less than. If you're by the open mouth, you've got greater than. And then you got further on, this isn't in this question, but you could have less than or equal, or you got greater than or equal. In this case, obviously, we don't have those, the second one's there. But here we've got from the box, choose a symbol to make each of the following statements correct. Well, we've got 5/8. Well, 5/8 is greater than 2/8. 5/8 is greater than 2/8. So it's a bigger number. 5/8 is obviously bigger than 2/8. And then we got below, we got -2 times -3. Well, you can put in your calculator, negative times a negative is a positive, so that would be 6. -3 plus 9, well, that's just the same as 9 take 3, so equals 6. And so our sign is going to be equals. So it's a relatively nice question again. Really nice question again. All right, so next we got a question where definitely having your calculator is going to save you a lot of time. So again, we're dealing with averages in this next question. So we've got here, we got the table shows information about the number of social media accounts used by each of 300 students. And the first question, we just got to work out the total number of social media accounts used by these students. So the way you would do that to find the total, we've got the number of social media accounts and we've got frequency. So in other words, 3 students have 0 accounts, 57 have 1 account, 84 have 2, 75 have 3, 81 have 4. So we can just add a column here, which is total. To get to total, we just need to multiply these numbers together. And then if we add them all, we're going to get the total counts. So 3 people have 0 counts. Well, the total is 0, of course, because 3 times 0 is 0. 57 have 1, so just be 57. Then we've got 84 have 2, so 84 times 2 just gives us 168. Then we've got 75 times 3, which is going to give us 225. And we've got 81 times 4, which will give us 324. Then we need to add them all together. I think it's 774, but I'm going to put it into my calculator to double check. Yeah, it is indeed. If you add them all together, it's going to get to 774. All right. So next we've got to find the median number of social media accounts used by the student. And so to find basically the median of a group, we know there's 300 students in total. And so we need to find out which group the middle number is in. So median, this is a mathematical way to know where it is, equals total plus 1 divided by 2. So total 300, so we've got 301. So 300, 301 divided by 2, which is going to give us 150.5. And what that means, if it's 150.5, we need to find the 150th and the 151st result. Well, hopefully they're going to be in the same groups. So 0 equals like 0 to 3 because we got the first ones. And then we can add on. So we can say 1 equals 4 to 60 in effect. Because if you see what I mean, it's the 3 in the first group plus a 57. So it's like the fourth result up to the 60th. And so 2's going to be from the 61st result to the 144th result. And we're looking for 150.5, so we still haven't reached it. But we can be pretty sure it's going to be in the next group. So I'm going to change colour just because it's going to be 3 equals from 145 to 220, I believe. But regardless, it's going to be in this group because the 150th and the 151st are in this group. So be number 3. And again, you could just add them all, but you wouldn't need to show some work in here. So you do the 3 plus the 57 to get you to the 60, plus the 84 to the 144, plus the 75, which actually, sorry, I should get you to 219. That's a little slip I made on on the end. It should be 219 here. But it doesn't matter regardless because 3 will be in that group because the 150th and the 151st result are in that group, which means the median number of social media accounts is 3. Okay. This next question here, we've got a question to do with scales. So again, it's a little bit different. Like a lot of questions in this exam, it's a little bit fiddly for that reason, but good practice not to have. And we're told on a scale drawing, a building has a length of 12.4 centimeters and a width of 9.4 centimeters. So we're told the real length of the building is 62 meters and the width is 9.4 centimeters. So we know 62 meters equals 12.4 centimeters. This time I'm not going to be using any mental maths. I definitely do need my calculator. So we need to do the scale equals 62 divided by 12.4. Actually, I think that will give us 5, but yes, double check. Divided by 12.4. Yeah, sure enough, it gets us to 5. And what this means is 1 centimeter equals 5 meters. And so now what we got to do, we know the width is 9.4, so true width, or real width would probably be a less weird thing to write, but true width equals 9.4 times by 5, which I believe will give us 47. Yeah, exactly, which gives us 47 meters. So our final answer is 47 meters. So yeah, with a question like that, a scale factor, although it's a different question, although it looks different, it's not too different than math from when you're dealing with things with scales, like when you're dealing with ratios, you're effectively finding a scale factor here, or when you're dealing with similar shapes which have a scale factor, or when you're dealing with recipes. All of these things have scale factors, so there is crossover between them. All right. So just going to do, I think this will probably be the last question today. We've got a bit of a graph to finish with. We got here, we have got question number 17. In fact, what I'm going to do, so I can make the graph a little bit bigger, I'm going to copy this into 2 parts. So we're being asked here to, on the grid below, draw the graph y equals 4 minus x for the values from x from -2 to 4. It's a bit low. I'm going to pop it a bit to the right, in fact. Just give us a bit more room. I'll scroll down a bit further. You can hopefully you saw it as a 3-mark question. Okay, so we've got a graph here in the form y equals 4 minus x. We haven't got any squared or cubed, which means it's a straight line graph. So remember, equation for straight line graph equals y equals x plus c. Definitely got a mental block on the m value for a second, but it came back luckily. So the m, it tells us the gradient or how steep or how much y changes for every x. And the c just tells us the y-intercept. So basically what y will be when x is 0. So we want to write this round in that way. So we can rewrite this round, just put our x bit first. So we can say our graph, we've got y equals 4 minus x, but we could always write it as y equals minus x plus 4. So you can see I've just split these two round to put into the y equals mx plus c form. Now we can draw out our table below of values. So sometimes you're given a table, this time we weren't, but if you're not, just draw out a table like this. All right, and we got the values of x, we've got minus 2, minus 1, 0, 1, 2, 3, 4. Well, remember C means the y-intercept, so that means what y equals. So y-intercept is what y equals when x equals 0. So we can just put a 4 there. The minus x, remember it just means minus x just means minus 1 x. And what it means minus 1 x. And what that means is for every time x goes up 1, y will go down 1. So if x equals 1, y will equal 3. We're going to go down 1 each time. In the other direction, we'll go up 1. If you wanted to double check this by putting numbers in, you could say like if x is minus 2, then we could put into our equation. So we could say y equals minus so how you do it out is like it would be almost like minus minus 2, which would just be 2, and then plus 4, because the two negatives cancel each other out to make the positive, plus 4, which equals 6. And we can do that sure enough here. So remember, the gradient just tells us how much y changes for every 1x. So if it's minus 1, that means y goes up 1. The y-intercept tells us what y equals when x equals 0. So we've got that here. So we can plot our graph, and it's just going to change 1 each time. So we've got 1, 3. Got 2, 2. You really only need to be honest, I'm putting all these spots, but you could just do the first and the last one because it's a straight line. So we'll just go through all of them. And you just want to go from, you don't want to draw beyond the lines. Obviously, if you're drawing a graph yourself, there's a calculator. Maybe you shouldn't have to, but you want to use a ruler because you don't want to draw as terribly as I've just done. I'm going to have one more go, but unfortunately, in my maths repertoire, drawing straight lines with rulers doesn't come into it. That's slightly better, but obviously if you were doing this in a paper exam, you'd use a ruler. If it was on the computer, I imagine they'd ask you to input the coordinates and it would draw it for you, but that's just my assumption of how it would work. All right, well, we're going to leave it there for today. So thanks so much, all of you, for your concentration. Obviously, we've got the last lecture of this series tomorrow. So we are going to jump through from question 18 to the end of this paper. And so, as I say, the questions always get progressively harder. So these will be the more challenging, the more like level 5 questions on the exam. But yeah, thank you so much. Hope you all have a great night and hopefully see you back here tomorrow. Okay, you're welcome. Bye bye.